right, let's continue on number 6. The number of lions in several prides are listed below. 12, 15, 23, 13, 18, 14, 21, 14, 18, 11, and 15. Our question, though, is what is the range of the data? Before we even look at our data again, we are going to define range. Think about Ariana Grande, right? She can sing really, 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 really high. She can also sing really, really, really low. Taking the high minus the low is going to give us our range. And so we'll take a peek. I'm going to grab a little highlighter. Our highest number, I see 23. Anything higher than 23? All right. Then we can always double check it later. Our lowest number, I see 12, 13, 14, 11. All right, I see 11. Anything lower than 11? No. Anything higher than 23? No. So our range is 23 minus 11, which gives us, boom, 12. There we are. All right, there's range. Let's look at question 7. All right, question number 7. Which of the following would yield variable data, making it a statistical question? Remember, variability, variable, vary. The weather varies. What we eat in a day varies. Variety, right? A buffet has a variety of foods, lots and lots of different foods. So variable data, as scientists, as mathematicians, we want to ask a question that is going to lead to different answers. Abbreviate that there, right? Different answers. So if we were to ask how far is it from Dallas to Austin, generally we're going to get the same answer, right? Yes, you could take a different route, but the straight shot is just up 35, and that is a finite number. So that would not yield variability. No variability. What is a typical weight of an adult Pomeranian? Well, the typical weight, an adult Pomeranian, so we have an adult, so not a puppy or a middle-aged dog, but like, adult, and a full-grown dog, and a specific breed. So because this is so specific, we are going to get one answer, right? If we ask vets, we're generally going to get one answer, so that is not going to yield variability. What was your math grade for the third 6 weeks? If we asked everybody in here, what was your math grade for the third 6 weeks? Would we get different answers? Some of us might say 85. Some of us might say 92. Some of us might say 88. Some of us might say 70 or 95. We could get lots of different answers. All right, how many people were in line at McDonald's on Barnett Road at 6:30 p.m. on a Monday? That is very specific. McDonald's, Barnett Road, at this exact time, we're going to get one answer because that's very, very, very specific. So our answer for this one is indeed going to be your grades for this 6 weeks. If we ask that to everybody, we would get so many different answers. All right, let's move on to question number 8. The box and whisker plot, another box and whisker plot. All right. Shows a number of hours that 500 teenagers spent listening to music on the radio each week. Which statement is best supported by the data? I feel like it should say on YouTube or on Spotify. We'll go old school with this, on the radio. All right, let's see. We have a lot of information here. So what I want to do before we start anything, and this will be good practice for us too, is I want us to label all of our little parts. And if you have forgotten, remember, this represents 100% of our data. And it's broken up into 4 parts, right? Quartiles. So that means each quartile is worth 25%. 25, 50, 75%. Okay, that's going to help us remember which one is the first quartile, right? We have Q1 because 1/4 is worth 25 cents. We've got Q2 because 2/4 is worth 50 cents. Q3 because 3/4 is worth 75%. And then Q4 because 4/4 is worth $1. Okay, I just wanted to jot that down in case whenever I see a box and whisker plot, I like to do this at least on one question so that I can go back and use it as a reference. I don't have to do it every single time. I can just have this kind of written down as a note to myself, even though it didn't take very long. Right, so then we've got our lower quartile, our median, and then our upper median, our minimum, and then of course our maximum. Awesome. Quick little things. All right, which statement is best supported? So I'm going to jot down, we want something that is true. Okay, sometimes when we have a lot of words like this, it's easier to just jot down true or false, and then we can make notes to ourselves on our answer choices. The range of the data is 15. Well, range means the highest high minus the lowest low, right? High minus low. So for us, that would be 15 minus 5 equals 10. That didn't really match up, did it? False, so I'd mark it off. We'll grab a new color for our next one. Let's see if we can make it into purple. The interquartile range is 10. All right, interquartile is a fancy word for, trying to give you a hint here, for the box. So we want the range of the box. Maybe I'll use yellow for this. That means interquartile range, we want the high of the box minus the low of the box. High of the box minus the low of the box. High minus the low. So that looks like, let's see, 12 minus 7, which definitely is not 10, right? It's 5. So that looks false as well. All right, let's grab another color. The greatest number of students listened between 7 and 10 minutes. 7 and 10 minutes. So I'm just going to highlight from 7 to 10 is this quartile right here. Okay. The greatest number of students. All right, I'm going to remind you guys of something that we already identified. What percentage of our data is in each section? Each quartile equals 25%. They all have the same amount of data. They all have the same amount of data. They all have the same number of people represented, even if it looks big or small. Remember, if it looks big, that just means the people, the data in that section are just really different from each other. If it's really small, then it means that they're just really similar. So we can't say that the greatest number of students watched between this amount because each section has the same amount. They all have 25% of the data, so that would be false. All right, let's prove without a shadow of a doubt this last one is our actual answer. Half of the students listened between 10 and 15 minutes. All right, so 10 is right here. 15 is here. All right, you guys, that is 2 quartiles, right? 1, 2. Each quartile is worth 25%. If we have 2 of them, 25%, 25%, together that is half, right? That's 50. So that is true. That is true. Again, right? From 10 minutes to 15 minutes is 2 quartiles. See if I can make that a little bit more obvious. From here to here, it's 2 quartiles, 1, 2, 25%, 25%, that's half, all right? 50%. Lots of little nuggets, but we have all of that in our brain. All right, here we go. The basketball coach listed the team's scores last season. The team had the following scores: 60, 62, 75, 78, 78, 78, 80, 83, 85, 88, 91, 92, 95, 98, and 115. What is the lower quartile? Ooh, lower quartile, aka low median. The lower median. So I kind of helped you out with some color coding here. If you notice, I already kind of found the median for you guys and highlighted the lower data and the upper data. Because remember, when we are working with, I know it doesn't say a box and whisker plot, but the fact that we're talking about a lower quartile means we're talking about a box and whisker plot. So our first step, step 1, find the median. Step 2, find the low median. Step 3, find the high median. And these make your box, right? And then we know our whiskers are our highest number and our lowest number. So let's focus on this. First, let's make sure I didn't goof, because I'm not immune to goofs. So let's make sure 83 is actually in the middle. 1, 2, 3, 4, 5, 6, 7 on one side. 1, 2, 3, 4, 5, 6, 7 on the other side. All right, so far, so good. I'm going to erase this side because we want the low median. That means we have our overall median, and now we need to find the median of our lower data, what I highlighted in yellow. So we'll knock off a low and a high, a low and a high, a low and a high. I got 78, but let's make sure there's 3 on one side, 3 on the other. Boom. All right, so again, it didn't say specifically we're working with a box and whisker plot, but when we see lower quartile, that should be like a red flag or a light bulb going off that we're going to have to think in that way. And we don't have to go very deep in it. We just have to lean on the basics that we know, right? We have to find our median. We know that our lower quartile is our lower median, and that's exactly what we focused on. We focused on our lower data. All right, let's take a peek at question 10. Mr. Wright surveyed his students to see how many minutes they spent per week on homework. The results are shown on the stem and leaf plot on the right. Which statement is best supported? Ooh, that means we want something that is true. True. Okay. So let's just take a peek and remind ourselves how to read this, right? We combine them, our 10s and our 1s. So this would be like 100, 103 minutes, 104 minutes, and so on. All right, so now that we have that understanding, let's see what we can figure out. Fewer than half the students spend 120 minutes or less per week on homework. 13 students spend 0 minutes on homework. The graph shows the data. Ooh, I like to work on the quick ones first and see if we can maybe pick or choose or eliminate some of the quicker ones to deal with. If we have to do some of the harder ones, we'll save those for last. I'm going to work on the last one. The graph shows the data for 13 students. Remember, our stem is just a way for us to organize our data. Our leaves represent the people, right? We had 3 leaves because that represented 3 students. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that's 9 people, not 13. So that is out. No go. 13 students spend 0 minutes on homework per week. Did anybody spend 0 minutes on homework? We just decided that there are only 9 students even listed on this, so there's no way that 13 spend it. What this 13 right here represents is 130 minutes. All right, so little things we can do. We already gave ourselves at least a 50% chance in getting this correct, and we didn't even have to do much work, which is pretty awesome. So let's see if we can continue with our others. Let's see. This one looks like it's a little less work, so let's focus on the first one. Fewer than half, so less than half of the students spent 120 minutes or less. So 120 minutes. Well, this is 122, so that would be here. Fewer than half. Well, 3 people spend more, and 1, 2, 3, 4, 5, 6 people spend less. This is wrong, right? This would have to be more than half, right? More than half. 6 people out of 9, that's definitely more than half. So that's out. They actually had it backwards. So now let's take a peek at what we're going to do next. The number of students who spend 120 or more minutes is less than the people who spend less. Well, we kind of just did that, didn't we? This one looks really wordy, but all we're saying is the students who spend, and we'll color code it. Let's make these people yellow or lime green, who spend 120 minutes or more. So that's these people. Is less than the number of students who spend fewer. Well, that looks true, right? Right? We're saying that these people spend less than these people. Yeah, that's true. Awesome. All right.